So hello guys, I welcome you all to this third video in the series of physics questions till your NEET exam. So yeah, first question from is from the topic of thermal physics. Yes, you have a PV diagram over here, isn't it? And 2 gram of helium gas is there. That means half mole is there, isn't it? Half mole of helium gas is present for a certain process A to B. So this is going from A state to B state, right? So this is from A to B as shown in the figure. So a PV diagram is given. What is the heat given to the gas during the process A to B? Okay, we need to find out delta Q is equal to what, right? So we know the information that is like we don't necessarily put it as delta Q, isn't it? So Q is equal to delta U plus delta W. Whenever you give some heat to a gas, some part of that will be used for increasing the internal energy of the gas, and the rest of the heat which you are giving is used for work done by the gas. So this is your thermodynamics equation. If you remember the laws of thermodynamics, this is what I will be using for solving this, right? So let's find out what is delta W. So work done is equal to the area under PV graph. You are aware of that, isn't it? Work done is given by area under this PV graph. So it is this. So if this is a trapezium, so let me find it out with the help of this area of a trapezium. I'm just splitting it into a triangle and a rectangle like this. So for this triangle, my area is half multiplied by base is this much, isn't it? So 2 P naught minus P naught is this much. P naught multiplied by height. This is this much distance. That is 2 V naught minus V naught is V naught. Hope you got this. So area of the triangle forming this trapezium is half P naught V naught. And this area of rectangle is also important. So this length into breadth. So this length is V naught and breadth is P naught itself. So this area is actually P naught V naught. Fine. So half P naught V naught plus P naught V naught is total area is 3 by 2 P naught V naught. And that is your work done. Okay, right. But how will I find out delta U? Delta U is NCV delta T, isn't it? Helium is a diatomic gas, H2, isn't it? H2. N is half mole. I will just keep it as N as of now. Multiplied by 3 by 2 R is the CV value multiplied by delta T. You know PV equal to nRT. So T is equal to PV divided by nR. Isn't it? So delta T is change in temperature, or I can say it as T2 minus of T1. T2 minus of T1 means this is T2, here the temperature was T1. So if I keep on writing this, N multiplied by 3 by 2 R multiplied by T2. What is the temperature at B? PV by nR. Pressure at B is 2 P naught multiplied by 2 V naught divided by N times R minus of here at A P naught V naught, isn't it? So this is P naught V naught, that is the pressure and volume at A divided by NR. Hope you are getting this. Now NR, these things will get cancelled off. Now what you are left with is something like 9 by 2. This is 2 minus 1 is 1, isn't it? So this is 2 P naught V naught. This is 4 P naught V naught minus 1 is 3 P naught V naught. This is 4 P naught V naught minus P naught V naught is 3 P naught V naught multiplied by 3 by 2 is 9 P naught V naught divided by 2. This is your internal energy change, right? So you can substitute here. Q is equal to delta U is 9 by 2 P naught V naught plus of what is work done 3 by 2 P naught V naught. Now this is equal to 9 plus 3 is 12. 12 divided by 2 is 6. 6 P naught V naught. Right? So this is your answer. 6 P naught V naught. My answer is option 2. Okay. So I hope this was a good question. This is an interesting question. But here just see this. Although it is given 2 gram of helium gas, this N value and even this gas constant is also cancelled off in this particular calculation. So I did not take up that particular value and substituted here. I did not go for N is equal to 1 by 2, 1 by 2. I didn't have to go for that. Okay, it got automatically cancelled off. And yes, it involves a bit of calculation, but a very good question, isn't it? It is a highly conceptual question. And here, temperature, when you find delta T is equal to T2 minus of T1, final temperature minus initial temperature. For each temperature, I substituted PV by NR, where P is the pressure at that point, volume of the gas at that point, N and R are constants, right? So I hope you like this question. Let's go to the next one now. So guys, this is the second question and it's a very fairly easy question and quite a routine question as well. The length of a metal wire is L1 when the tension when the tension in it is T1. So when it was T1, the length is L1. When it is T2, the length is L2, right? The unstretched length of the wire is. The unstretched length of the wire is. The concept is very simple. Force is equal to K multiplied by X. So here the force in the first case, T1 is the force, isn't it? T1 is equal to K multiplied by, this is the change in the length. So let us suppose initial length is L0. Initial length is L0 and in this case when the force becomes T1, the length increases and here the length is L1. So the change in length is L1 minus of L0. Initially it was L0. When you pulled it with the tension of T1, the length became L1. That's it. And similarly in the other case it is K multiplied by L2 minus of L0, isn't it? Now what you can do is simply divide this. Simply divide this, and if you do this, it's a very simple calculation to do this. Finally, you will cancel off this K and K can be cancelled here itself, and you will get the unstretched length, that is L0 is equal to L2 T1 minus of L1 T2 divided by, how much will that be? This will be T1 minus of T2. Right, so this is the answer that you're going to get, and if you take a minus sign, if it is removed from both of these, if you multiply throughout by the minus sign, what you're going to get is this option number 3. So yes, the correct answer for this question is option 3rd. Now this is a fairly easy question in a way. It's easy in a way, but I don't know if this is a normal trend in the concept of case of NEET exam in your national eligibility cum entrance test. We seldom see questions based on the plane mirror, isn't it? But here you have a question from plane mirror, so I thought of just discussing this with you. If at all something happens, or if a question from plane mirror comes, you will be at least to give you an idea. Oh, this is something that I saw in the question paper that I have got, so I thought of discussing this with you. So here they are saying that they have a wall like this, isn't it? And they named their wall as W. Okay, let it be there. Now we have a mirror here. Now this mirror is somewhat like this. This is my mirror and this mirror is M. Now what to do after this? See, if this is the gap between both these, if this is the gap between the mirror and this is the gap between the mirror and the wall. So just to make this interesting, let me make things like this so you can understand. This is a dotted line showing the gap between the mirror and the wall. Okay, and they say that the length is L between this, and you have a source over here. This is the source. So, and this mirror is moving towards the wall. So this is the mirror. Mirror is actually moving towards the wall. I'm not wanting to destroy this diagram with the help of too many things like this. Too many markings are not something that I prefer here. Let me write it here. This is the mirror and this is the wall. Fine. Now see, a flat mirror M is arranged parallel to the wall at a distance of L from it as shown in the figure. Yeah, something that we have made it here. The light produced by a source, point source S kept on the wall is reflected by the mirror and produces a light patch on the wall. Okay, so if this is the source S, we'll consider two extreme conditions here to make the ray, isn't it? So which color do you prefer here? This, let this be there. Now one ray of light from S will come over here, and from there again this will be reflected over here, and this will be making a image over here. Say one part of the image will be over here, and this S is going to send lot of ray of light towards this mirror, but the last ray of light towards the end of this mirror will be like this, and from there This is how the ray looks like, isn't it? Somewhere here. So yeah, I will have to modify my diagram somewhat. Let me rub this off and let me make this continue here. This is my wall and here comes the patch. Now this is my entire area of the patch. So this light which is emitted by this, I am taking the two extreme conditions over here so that this entire area will be the area of light on the wall. Okay, this is the spot or the patch they are saying. This is the patch. Okay guys, so this is the patch that you can see over here. So the rays that I have considered is the extreme ends of this particular patch. Okay, so the patch is somewhat like this. Here there is no color. Up to this is the patch. To be exactly precise in making the patch. Okay, this is the patch of light over here. Fine, let me make this point as P. Let this be A, and this point let it be say Q, and this is B. Now tell me, this ray of light is going here, hitting the mirror and coming back. So this SP is equal to PA, isn't it? So I can write SP is equal to PA. Similarly, I can write SQ is equal to QB. See, this much distance and this much distance should be equal. Although it is not very clear from the diagram, these lengths should be the same. The length of SQ is equal to length of QB. Although it is not, I could not make it exactly correct in the diagram. It should be correct because this is a plane mirror. So this is a plane mirror, isn't it? This is a plane mirror. So this much distance that it travels, the same distance should it travel here, because this wall is actually horizontal. A very horizontal plane wall has been given. So SP is equal to PA and SQ is equal to QB, isn't it? So that means position of A, this part and this part is not dependent on the length between or the distance between the mirror and the wall. Right? So even if the mirror goes from this position to this position, even if the mirror comes to this position, still what will happen? What will happen as a result of that? Then the new ray will come and hit over like this, and it will again go and hit over the same A point. Here also this will go and hit over here, and it will again hit on the same B point. That means my patch which is present, which is actually obtained on the wall, is remaining unchanged. So I can say A and B are independent of the position of mirror, because of the arrangement is such that the mirror and the wall are exactly parallel to each other. So if the mirror goes towards the wall or away from the wall, the position of the image will not change, right? This is just a more of a common sense kind of a question. Try to understand this. I hope this much of information is sufficient for you to understand this. It is very easily acceptable, very easily understandable with the help of this particular image that I have drawn over here. There is nothing very much to be done mathematically to prove this. Nothing of that kind is required. So yeah, path of the light will not move on the wall, will be my correct answer. So this is a good question, but yeah, very understanding based simple question that they have asked over here. So if you are not understood this, try doing this over here and ask to yourself what will happen if I move this over here, right? SP is equal to PA. If the source is fixed over here, both the wall and the mirror are parallel. These two things are parallel. So from the source, if one point comes over here, it has to travel the exact same distance and fall over here. Similarly, now when my mirror is transposed to this position, when it comes to the new position here, what happens is the source is again sending the wave, again it will be falling on the same spot. Why? Because SP equal to PA. Then also it has to maintain the same thing. Now the mirror is exactly following the same path, isn't it? It is directly perpendicularly. See, the path traversed by the mirror is exactly perpendicular to the wall. It is falling exactly perpendicular. It is moving exactly perpendicular to this. There is no deviation. If there is a deviation to this side or that side, then you will be saying that the patch can move to this side or that side. But the point is, since the mirror is moving in exactly perpendicular way to the wall, there is no change in the position of the image. So that will be the explanation for this question. So let's go to the next question. So if you see this question from fluid mechanics, again a very typical question, but yeah, very conceptual based question. Most of the questions in Neet will be like this. So I thought of taking these kind of questions today. An air bubble of 1 centimeter radius. Yeah, the point is that there is a catch when you come to the units over here. It's in centimeter, gram per centimeter, centimeter per second square, and the units of the answer is in poise. So yes, everything should be in centimeter, gram and second. So this centimeter should be there, gram should be there, and second should be there. So this is what you need to go on solving. Make sure that all the units are in these quantities, or the unit should be having these quantities. If it goes into meter or kilogram, then it will not work out, right? Everything should be in centimeter, gram and second. That's all. 1 centimeter radius is there, it is rising at a steady state. Okay, so it is rising at a steady state, so it simply means that you can use the equation of terminal velocity. 2 by 9 sigma minus rho gr square divided by eta. Now what are they asking here? Neglect the density of air. So here the density of air, I mean air bubble, it is air bubble, isn't it? So obviously you will simply have to take this, just remove this, because we just have to neglect that, right? And the sigma is given to be 10,000. If g is given to be this much and liquid of density is 1.5, isn't it? Yeah, so in place of sigma you can substitute that. So this is 2 by 9 multiplied by sigma is 1.9, 1.5. Rho you will have to neglect it, because they have said that neglect the density of air, you don't have to care about that. Okay. G 1000 centimeter per second square, 1000 multiplied by r square, it is 1 square. Okay, and eta is equal to 2 millimeters, isn't it? This is in millimeter. I said everything should be in centimeter, gram and second. Here it is millimeter per second, so I have to convert this into centimeter. So yes, it is 0.2 centimeter, right? So what you can do is, it's a very simple calculation. You can cut this off, 10 raised to minus 1. Now yes, 3 into 3 are 9, 3 into 5 are 15. So this is 5 into 10 raised to minus 1. So you can simply cancel this off. So eta is equal to 5000 divided by 3. So this is around 1.6 into 10 raised to 3, isn't it? 1.6 into 10 raised to the power 3. Unit is poise. So for getting the unit poise, I told you to make sure that you are following these three things. So what is the answer then? 1.6 into 10 raised to the power 3 poise. So the answer for this question is option 3. So with that, we come to the end of the physics discussion for today. So tomorrow we'll come up with other things. So I am planning to discuss many questions from radioactivity also, because radioactivity, very typical questions are asked every year, and if you know some basic questions in radioactivity, you can solve any question that they are asking in the NEET exam, because questions are very typical these days. But the point is, I forgot a lot of concepts in radioactivity. So if I can just refresh my memory before tomorrow's class, or I mean tomorrow's video, day after tomorrow's video, I will surely make a video on radioactivity. So I can guarantee that that much questions are sufficient for you to crack any question that they are planning to ask in radioactivity. That much will be enough for you. Okay. So with that, we come to the end of this video.